Hello everyone! Today we are going to talk about PWM and what you can do with it. PWM stands for Pulse Width Modulation, and it consists of producing a square wave which you can control the up or high time. In a PWM signal, the minimum and maximum voltage are the values that limit the wave's oscillation. The space between them is called amplitude. A cycle is the interval of the wave where you can find one full repetition. The time a cycle takes to finish is called period, and the frequency is 1 over period, which gives you how many cycles are in a time unit, usually a second. A very important concept in PWM is the duty cycle. The duty cycle represents how much of the period in which the signal is high. In our wave, the signal here is high, and here is low. To calculate the duty cycle, you need to know how much of the period the signal is high. Let us set our high time as 6 milliseconds, our downtime as 4 milliseconds, and our period as 10. Now, let's use a simple rule to calculate the percentage of the period in which the signal is high. 6 relates to 10 the same way as our variable in percentage relates to 100%. If you solve this, you'll see that you get 60%, meaning that the signal is high 60% of the time. Let's imagine a PWM signal that oscillates between 0 and 5 volts. Let's say this signal has a duty cycle of 50%. Something interesting will happen to the output voltage. Instead of being 5 volts as expected, it will now be 2.5 volts. Simply putting it, this is because in a PWM signal you multiply the max voltage by the duty cycle. This is the formula. By applying this to our situation, you will see we will reach 2.5 volts. Let's see what happens to the different components of the wave when I increase the duty cycle. As you can see, when I increase the duty cycle, the output voltage also increases. And when I decrease the duty cycle, the output voltage also decreases. Keep in mind that the output voltage can only oscillate between the minimum and the maximum of the PWM signal. Now, let me show you this example in real life. We are going to use an Arduino, a breadboard, a LED, and any resistor between 1K and 300 ohm. If you look closely at an Arduino, you'll see some pins have a tilde symbol. This means these ports can output a PWM signal. Now let us set up a simple LED configuration. Connect the Arduino power to the breadboard. Next, place the LED on the breadboard and also the resistor between the LED and the ground. Now, simply connect a cable between any port that can handle a PWM signal. Last but not least, we have to create a program to control the PWM port. Assign the port that you connected your LED into a variable. I will call it PWM. Now, this byte variable will represent the PWM value. The reason I chose a byte variable is because the PWM in the Arduino has a resolution of 8 bits. So you have 8 bits or a byte to encode the value of your duty cycle. 0 means 0% and 225 means 100%. In order to control the PWM ports in an Arduino, you use the analog write function. The first parameter is the number of the pin which you want to control, and the second is the value of the duty cycle ranging from 0 to 225. We want the PWM value to slowly increase with time. For that, we will increment the variable each time the program goes through the loop. In order for this process to be slow, we will have to introduce a little delay. 20 milliseconds should do. Now, we don't have to reset the byte value, because when it reaches its maximum or 225, it becomes 0 again. At your left, you are looking at my old oscilloscope showing the PWM signal. At your right, the LED becomes brighter the higher the duty cycle, and it becomes less bright the lower the duty cycle. Thank you for watching, and I will see you in the next video.